Good morning, dear students. How are you all? So in this video, we will talk about yet again the concepts. And the very first question you can see, how will you justify that curdling of milk is a chemical change? Dear student, for that I will say that you have to understand the curdling of change first of all. And here you can see, dear student, curdling of milk is a chemical change, and you can say that what is chemical change first of all you have to understand. Okay na? So you can say that chemical change means one change which can be permanent. First point is permanent in nature. Second one, if I will write, then new substance for, and that new substance which have new properties also. This new substance have new properties also. Only in that case we can say the changes is chemical change. Okay now, so now you can read that one. Curdling of milk is an example of chemical change, and you can see that if milk will change into curd, a new substance is forming. Okay now, so, and the properties of milk and curd are also different. So you can see here is the point given, milk and curd are also different. Okay now, you all know that milk is sweet in taste but the curd has sour taste. Okay, and formation of curd is a permanent change. Never you will see that yet again you will find the milk from that curd after breaking, after decomposition. So hence it can be called as a chemical change. Okay now, you can see that one. Okay, so the formation of curd is a permanent change. It means that once curd will form, it cannot be changed again into milk. Okay, and hence it can be called as a permanent change. Now you can see second question, what would you observe? What would you observe when a saturated solution of potassium chloride prepared at 60 degrees C? Means you know na, 60 degrees C means interparticle space widen up and more amount of solute you have added. That is cooled to room temperature. Means 60 degrees C is there and you have to go at room temperature. You have to decrease the solution, decrease the temperature of the solution. Okay na? So just try to understand, 60 degrees C was the temperature, initial temperature. Now you are decreasing to go towards the room temperature. Okay na? So what will happen in that case? Second question, you can see an aqueous sugar solution is heated to dryness. A mixture of iron filling and sulfur powder is heated strongly. So three cases are there, you can see. Okay, so these are questions I will discuss first of all, and then I will give you the answer of all the cases. Here, dear student, you know the first case, very first case, if I have one liquid and that liquid is water. Okay, this water had some interparticle space. Okay na, had some interparticle space, so some solute will be added. If suppose it is at room temperature, initially it is at room temperature, 25 degrees C is the room temperature. So how can I increase the temperature? I will increase the temperature by heating. Okay na, I have given heat to that one, the temperature will increase. In the question it is given that a saturated solution which is formed at a 60 degrees C. So anyhow I have given 60 degrees C. Now more amount of solute, because interparticle space will widen up. Yes, so more amount of solute will be added into that one. So you can say solubility, direct effect. Yes, solubility is there. So dear student, solubility is directly proportional to temperature. Okay na, here I have written. Now in the question it is given, in the question you can, a saturated solution of potassium chloride prepared at 60 degrees C is allowed to cool to room temperature. What will happen? So you can see that solubility, solubility, is directly proportional to temperature. Okay na? So if I will decrease the temperature, where the extra amount of solute will go? Where the extra amount of solute will go? That will remain settled down, that will present into the solution. So we can say that if temperature will decrease, means from 60 degrees C, it is going towards 25 degrees C, room temperature, it is going towards that temperature, that means solubility will decrease. Okay now, that is the direct relationship. If temperature will increase, solubility will increase. If the temperature will decrease, solubility will decrease. Take the second question. An aqueous sugar solution is heated to dryness. An aqueous sugar solution, now you know dear student, aqueous sugar solution is one solution which, in which the water is present, in which water is present. So if I will heat that one, water will evaporate. Yes na, you know dear student, water will evaporate. And if I am keep continue with the heating, then water has evaporated already, then only sugar is present. Sugar is getting absorbing the heat. What will happen? Sugar will become charred and the charcoal will form. Okay na, sugar will actually become charred when black substance will form. Okay na, lots of heating if you will provide, sugar will become charred, black colored will form. Okay na, that is called as a charcoal. Okay, now second question, next question, you can see a mixture of iron filling. So what is the formula, what is the element? Fe, iron filling, iron powder, yes na, sulfur, Fe plus S, it will form FeS, Fe2 positive, 2 negative, so it is the compound. So you can see, now I will give the answer and it would be simple, very simple. You can read that one. Okay na, if you have understood, then you can read that one. Now next thing, yes, the emission effect is actually applied on there. Yeah, this is the part of the third questions. You can read, when the mixture of iron filling and sulfur powder is heated, okay na, then chemical change take place and it will form iron sulfide, which is a compound. Okay na dear student. Now the next part of the question, yes, next question is under which category or mixture? Yes, under which category or mixture? Mixture, there are two types of mixture, homogeneous or heterogeneous mixture, you know na. Alloys and yes, sorry, under which category or mixture will you classify alloys and why? Under which categories? Means mixture are two types, homogeneous mixture, heterogeneous mixture. Dear student, alloy classification according to you, in which categories you want to keep the alloys. Okay na, so I will keep this alloy here in the homogeneous mixture. Homogeneous mixture. Why? The point is why. Now I am telling you dear student, alloy is the true solution or solid solution. Okay na, alloy is a homogeneous mixture. Alloy is a homogeneous mixture, so we can say it is a true solution, solid solution. Okay, I am giving you some example of alloy. Brass, it is made up of copper and zinc. Steel, it is made up of iron and carbon. Carbon is a non-metal, so here the theory is changed. Alloy can be made by mixing non-metal also. Some percentage of non-metal can also be made. There are different types of non-metal, there are different types of alloys. So we can say irrespective of the fact, alloys are made up of different types of metals also, different types of non-metals also, variable compositions also. It can be categorized into homogeneous categories. Okay na, because the percentage is fixed every time. Because the percentage is fixed every, we can categorize alloys in the homogeneous mixture only in that case where the constituent or the component which is actually present into the alloy is actually retaining their properties. On that basis we can say alloys are the homogeneous mixture. Okay na, rest you will see in alloy variable composition are there. If variable composition, then it should be called as a heterogeneous mixture. Okay na, it cannot be separated by the physical method also. Yes, you cannot separate the constituent components of alloy by the physical methods, but still it, yes, it can be called as a homogeneous mixture. Okay na? In the homogeneous mixture, component cannot be separated by the physical methods, you know. Heterogeneous mixture, sand plus water, can be separated by the physical methods like filtration. Okay, but in the alloys it is homogeneous mixture because the component cannot be separated by physical methods and the component retain its properties. Okay na? Retain its properties. So you can you have understood. Second question is question number 4. A solution is always called a liquid. Comment. Comment. Right comment, wrong comment. Means you have to tell that a solution is always a liquid. We can say a solution is not always a liquid. Not always a liquid. You can write no, a solution is not always a liquid. Means a solution can be solid solution also, liquid solution also, gaseous solution also. You know, dear student, it depends upon the solvent phase. If there is solid solvent, then solid solution, and there are three types of solid solution: liquid solution, three types of liquid solution; gaseous solution, three types of gaseous solution would be there. But everywhere you will see why the name of solid solution is called, because of the solvent, because solvent is solid. Why the liquid solution? Because liquid is the solvent. Gaseous solution, because gases is the solvent. So every time you have to understand a solution is always a liquid. No, no, never. Okay na? Can a solution be heterogeneous? Can a solution be heterogeneous? No. Yet again answer is no. Solution never be heterogeneous. Solution never be heterogeneous because a solution is made up of solute plus solvent, and that mix properly. Uniform mixture would be there. So that's why it is a homogeneous mixture. Okay na? Now answer is given. Please student read that all the answer. Here I have given the answer. The alloys are called homogeneous mixture or solid solution of two metals along with some non-metals. And here you can see that I have given that one, this steel example. There are different types of steel. The first question's answer. So you can see that first question you will write in the copy and you will see the answer of that one. Steel, and they have variable compositions. Okay na? First answer, question number 3 answer is there, this one. Okay, so you can note down that one. Then after second answer, no, it is not necessary that a solution is always in liquid state, so I have discussed that one. And third, this one, no, a solution is defined as a homogeneous mixture of two or more substance. Okay na, dear students, so I hope all of you will do that questions. All of these conceptual question is very, very important. Please prepare these conceptual question as per the exam point of view also, because in the MCQ from that also it will come. So thank you for the video. Thank you all of you. Take care of yourself. Thank you.